Hi. Thank you, everyone. Thank you. We will look at 5 questions. The first is, what are the challenges that you need to address as developers when you are handling data at this scale and at this speed? Number 2, how have some of the best-in-class companies handled this? I mean, what are companies doing in this space? Why is it different? And there are some patterns that are happening as this happens. What is amazing is a number of products, technologies which have been developed just to handle this part of data. There are constantly evolving patterns to handle this problem. How do we manage that? How do we position UST Global in this space? That's the 4th question. And the 5th, and I'm sure that's the most interesting, how do you position yourself in this space? What do you do to stay ahead of this constant change in technology and make sure that you are relevant? Particularly if you're interested in handling this kind of problem, how do you stay ahead of the curve, or at least with the curve? Because the curve is moving really fast. So that is really the agenda for the day. One, you had initially, most of us, our applications we are used to is data at rest. What it means is there are applications, sensors, data coming into an event, and then you have databases storing that data. Then you have analytics, you have all kind of operations being done on the data, because the data is at rest first. When you have streaming applications, the real challenge is you're constantly evaluating the data against historical data, against a window of data if required, and responding back with results. Therefore, most useful streaming applications require state to be tracked. That means the event comes in, you also know when that event happened. You know who was in that event. You know what was the metadata around that event. You're capturing all that with that event, because then only you can make meaningful conclusions from that huge pipe of data coming in. Unifying stream processing data, therefore, unifies applications, data, analytics, all of it is coming together. This is where the future of IT is going to be. You will not have the time to manage applications at rest. You'll be reacting much more faster to data as it comes in. The best-in-class companies have solved it with solutions of their own. It's very interesting. Every company that you can think of, for example, HDFS, Bigtable, Go language, all of it developed by Google. Kafka, Samza, Databus, developed by LinkedIn. LinkedIn is not even a technology company. Presto, RocksDB, developed by Facebook. NiFi, it's an ingestion mechanism developed by NSA, the government department in the US. Keylin, for doing reporting in the front end from Hadoop, developed by eBay in China. Storm, developed by UC Berkeley. AthenaX, developed by Uber. Spark, UC Berkeley. Flink, the TU, Technical University of Berlin. So you have all these kind of players coming in. Our need for us as people, developers who need to stay ahead of the curve is to understand how this is happening, what do we need to do to stay ahead of it and stay with it. So one aspect of this huge problem, there are multiple aspects. Simply put, the ingestion of data, the processing of the data, using the data for analytics, machine learning, all 3 aspects are important. We are looking today at one aspect, streaming of this analytics. That means doing the calculations and transformations as the data comes in. So look at LinkedIn and what did they do. So LinkedIn's business is, one is of course giving all of us an opportunity to put our CVs out. They also have to give you meaningful information back. There are so many articles on LinkedIn, people are writing on LinkedIn. How does LinkedIn know what is important to you and send you meaningful content at the right time? Because that's how LinkedIn improves its own usability and usefulness to us so that we continue to use it. So what they did was, they had these kind of problems. Different parts of LinkedIn, the hiring part, the blogs part, the content part, they were all generating emails to send to targeted people. They had to merge it and send one email, because none of us want 10 emails from LinkedIn. But as you can imagine, each one is a stream. Collating that together, making sure they make sense, and putting it into one stream for you to use is a problem you're solving. And again, we're talking about millions of events per second because it's worldwide. Ad relevance through calculating 2 streams. One is, did you see the ad? Number 2, did you open the ad? the click-through relevance of that ad is a very important financial number for the clients of LinkedIn. How do you calculate that at that speed? So they had to solve that problem. They have to then look at the user events quality and make sure that people are really finding value by reacting to that event, commenting on that event, getting that feedback back, and then making sure that your engine, which is recommending content to you, is just doing the right things. So these are the problems that LinkedIn had. The problem was there was no solution that they had. So they developed Kafka as a messaging infrastructure, which could, the producer is all the content being generated. The topic is a content framework. Maybe it is news, maybe it is ads. Some category of content is a topic. So they broke up that topic into partitions. And then you could select a set of partitions on the right side into a server, so you could actually scale absolutely variably any part of this infrastructure. So a simple thing, like a message coming from a source going to a consumer, you could break up any part of it and scale it. Therefore, you could solve bottlenecks in terms of performance, back pressure of streams. All of it could be solved in a very flexible fashion. Why do they need it? They can increase everything and make it bigger. They just cannot afford it. They are making money as well. So the need is, therefore, a technology which allows them that flexibility. They developed this whole technology called Kafka. Everybody is using it now. 1.3 trillion events are published into Kafka by LinkedIn today. That is the size of the prize and the size of the technical problem. Then they said, okay, I've got Kafka, I've got data coming in. Now I have to meaningfully process it. And they had to do the streaming analytics on it. There again was no solution available. They developed a product called Samza. So Samza could break up that stream on the left, which is coming from Kafka streams, the partitions in which it is broken up for different category of information, process it, and the state, that blue box, is a database. In this case, they developed something, actually they leveraged a database from Facebook called RocksDB, a key value pair database, store it there, depending on what they need to store. The benefit is, since the state and the processing are together, the merger of applications, data, infrastructure is happening. So this is the solution that they had. And if you look at the numbers on the right side, 1, 2, 3, 4, and so on, they are keeping track of changes as it happens at relevant points so that they can go back, process it for something else, and all those requirements that they can meet. Local state, therefore you get fault tolerance, you can go back and repeat, all those things are part of that. What really is happening is the Kafka stream is getting broken up into tasks. Each task has a data store. The data store is on RocksDB. RocksDB was developed by Facebook to meet their challenges. This is another pattern we'll see repeatedly in this whole space. All the products which are being developed by these companies are all open source. Every product we saw in the previous list is open source. They are being leveraged by each other. Streaming, but we had to process it. And the processing needs ability to handle graphs, ability to run machine learning algorithms, manage windows, because the time in which you look at the events, the time as it moves, you're capturing those in sliding windows, tumbling windows, all kind of handling of the data in a meaningful fashion to really generate insights which have business impact. So that machine learning algorithms, the ability to handle it, again, there was no solution available. So that brought up Spark. Spark, as I said earlier, was developed by UC Berkeley. So Spark allowed you to really manage what is called a data set, which is resilient, a resilient distributed data set, or RDD. And a data stream, or D stream, consists of a series of RDDs. So you could manage parts of it, get those processed separately. So in some ways, it's a micro batch. So you're really not doing real-time processing, but you're doing batches, processing it, but at great speed. And this was developed by UC Berkeley. This became a fundamental part of many products, and many companies are using it. So if you really look at the typical 3 products, there are more products in this space, but Storm, which is Apache, Spark, by Berkeley, open source is Apache, and Samza, all of them have a source. They call it different things. Somebody calls it spouts, somebody calls it consumers. You have a stream primitive, which is how is the data stored in that message, in that core part of it, a tuple or a D stream in the case of Spark. And then you have the processing on that. The bolts process it for Storm, or you have window operations in the case of Spark. So all of them are the same concept. So what I wanted to kind of share with you was there is a pattern which is very similar. So it's not like you have to learn 10 different things, but you learn one of them well, there is a good way that you can pick up others very fast. The way we train our people, the way we get people on board for projects is changing. It's no longer 10-year experience doing something. What is required is speed. What is required is the ability to acquire knowledge and the ability to develop prototypes fast. So dream, develop, disrupt. It really means not just money, but now survival for all of us. What do I do better so that I can get the best mix of cost and effort and value? So these are the questions that you will have to answer when you talk to customers. What should I choose? Which one do I use? Is this the right choice for me? And how do we position UST Global in this space? That was the fourth question. So our approach is to build accelerators the way Uber built Athena X. We have built something called Cubes. We've got tie-up with startups. Hebrew University from Jerusalem, the Technion University in Tel Aviv, Stanford AI Labs. All of these are sources for us to leverage and build something new. Anuj has done something phenomenal with SmartOps, AI Labs, making that hardened, making it available, integrating it together, but focusing on making money. How do you make that effective for use by our users, for our customers, for saving money? Then you make money. So that is really the heart of our positioning in this space. Unique. Build domain solutions. You understand your customers' domains better than almost anyone. It's healthcare, it's retail, it's payer industry, it is TMT, or it is the BFS, our 4 verticals, or manufacturing. We understand what makes a business tick. What is the value stream? As data comes in, data goes out, there is some value being generated. You're creating something, you're giving a service. So that knowledge makes these solutions far more faster to go to market because you understand what the need is. So when you come in from a business point of view, from a customer point of view, you're bringing that knowledge. And cutting-edge university research I talked about. How do you position yourself in this space? Look for opportunities in your business. Look for where can this whole ability to handle data at scale change the way your business runs. You have to think of those ideas. They are the driver behind everything. Technology will come much later if you don't have this. Number 2, we have set up access to these tools in UST's portal.